Hello everyone, welcome you all to today's class. So today's topic is cross product of two vectors. And before that we already have studied dot product or scalar product of two vectors. Now let's focus on cross product or vector product of two vectors in today's class. So let's begin the class. So as you can clearly see the screen, so we are going to study vector or cross product of two vectors, in which we will be discussing concept of vector or cross product of two vectors, properties of cross product, and applications of cross product of two vectors. Right? Now, so regarding the concept, so if we take A and B, two non-zero vectors, then cross product or vector product of A and B, I mean two vectors, denoted by A cross B. Okay, so like in case of dot product, we used to write A dot B, dot was prominent, and we read it as A dot B. We do not read it as A into B. Right? Similarly, A cross B. So this cross should be prominent. It should be clearly visible. Okay, A cross B, we read it as A cross B, not A into B. Right? So the cross product of A and B denoted by A cross B, like this, is defined as A cross B equal to magnitude of A into magnitude of B into sine theta into n cap. Right? So magnitude of A is clear. Length of the, directed line segment A vector. Right? Similarly, magnitude of B, sine theta. Theta is angle between A and B. And of course, theta will be from 0 to 180 degree. Okay, then n cap. So here, n cap is what? N cap is the unit vector perpendicular to the plane containing A and B. So whenever we say it is the unit vector perpendicular to the plane containing A and B, and one of the characteristic of the plane is any perpendicular, normal to the plane, is perpendicular to all the lines contained in the plane. Right? So just like line contains infinitely many points. Similarly, a plane contains infinitely many lines. So any perpendicular to the plane is perpendicular to all the lines contained in the plane. So here when we say n cap is the unit vector perpendicular to the plane containing A and B, it means n cap is the unit vector which is perpendicular to both A and B. So in that way, so magnitude of A is a number, magnitude of B is a number, sine theta is a number, but n cap is a vector. So because of the presence of n cap, A cross B is a vector quantity. So what we should take from this definition? A cross B is a vector quantity. Okay, it is a vector. Now when we say it is vector, it will have direction and magnitude. Okay, any vector will be associated with direction and magnitude. Now direction is along n cap because the presence of n cap gives A cross B the direction. So it means direction of A cross B is perpendicular to both A and B. Right? It is perpendicular to the plane containing A and B, or simply we can say A cross B. The direction of A cross B is perpendicular to both A and B. And what about the magnitude? The magnitude will be A cross B. The magnitude will be magnitude of A into magnitude of B into sine theta. Okay, is it clear? So we have studied what is A cross B, how to denote it, and it is a vector quantity. Okay, and its direction and magnitude. So now next we will go to properties of cross product of two vectors. So first one is the cross product of two vectors. It is not commutative. So as I said, A cross B is a vector quantity. So whenever you change the order of the vector, right? So it means A cross B and B cross A. If you write A cross B and if you take B cross A, so when you are interchanging the position, the direction is being reversed. Okay, so A cross B equal to minus of B cross A. Okay, so it means unlike your dot product, in case of dot product, we were taking A dot B equal to B dot A. But here in cross product, position or direction matters. So whenever you interchange the position, here the direction of the direction gets reversed. So that is the reason you are getting A cross B equal to minus of B cross A. Okay, so it means it is not commutative. Okay, now second property, if two vectors are collinear or parallel, in that case, cross product of two vectors becomes 0. So whether collinear or parallel, so it means theta is either 0 degree or 180 degree. In both the cases, sine theta will be 0. So it means your A cross B equal to magnitude of A, magnitude of B into sine 0 or sine 180. In both the cases, you will be getting sine theta 0. Then n cap. So because again you are having n cap here, it will be 0 vector. Okay. It means here A cross B magnitude will be 0 because you are getting sine theta 0. Okay. So A cross B is a 0 vector. So it means whenever you have to see whether, the vectors, two vectors are parallel or they are collinear, cross product vanishes. Third property, cross product of two vectors is distributive over vector addition. That means if you have the vectors A, B, C, okay, now A cross B plus C equal to A cross B plus A cross C. Okay, and if you just change the order of this, if you write here A plus B, for example, cross C, it is A cross C plus B cross C. Okay, so order has to be taken into consideration. We have to be very careful here. And fourth property, so if you have two vectors, let A and B be two vectors and lambda is a scalar. Any number. Lambda is just like 2, 3, 5 minus 2. It is any number. So lambda times, if you write here, scalar multiple of A, lambda A cross B, that is equal to, so lambda can be anywhere. You may write here lambda into A cross B. Okay, vector product of two vectors. Or this is also equal to A cross lambda times B vector. Okay, it may be written like this. That means if A and B are any two vectors and lambda is any scalar, any real number, it may be positive or negative, so we can use this property like this. Okay, so these are the some of the properties of, I mean, cross product of two vectors or vector product of two vectors. Now third thing is we have to go for applications of cross product or vector product of two vectors. Why cross product is very very important in vector chapter. Okay, so first and foremost thing is to find angle between two vectors. So you know sine theta, I mean whenever you write A cross B, you are getting magnitude of A into magnitude of B into sine theta into n cap. And also we have studied magnitude of A cross B equal to magnitude of A into magnitude of B into sine theta. So from this we can get angle between two vectors, right? So it means sine theta equal to magnitude of A cross B divided by magnitude of A into magnitude of B. Okay, so because theta is from 0 degree to 180 degree, it means it is covering first and second quadrant. Sine theta is positive, so we don't have to worry for plus minus sign here. Okay, so sine theta equal to this. So we can find angle between two vectors by using this. Okay, is it clear? Next one is to check whether two vectors are parallel or collinear. So as just few minutes back we have studied, if theta equal to 0, if theta equal to 0 degree or 180 degree, you have sine theta equal to 0. So it means A cross B is a 0 vector. Okay, so what we can write here, A vector and B vector are parallel or collinear if and only if A cross B is a 0 vector. Okay, so in that way, if you take A cross A, for example, if I write here A cross A, if I take same vector, cross product of A cross, I mean A and A with itself, we may write like this, magnitude of A, sine 0, then n cap, right? So sine 0 is 0, so you will be getting 0 vector here. Okay, and also we can take, yeah, going in the same line, I cross I equal to 0 vector, J cross J equal to 0 vector, and K cross K equal to 0 vector. Okay, so it means whenever you take cross product of two vectors, I mean same vector, either you take linear vectors, या coincident vectors, या parallel vectors. Okay, because angle between two vectors 0, so you will be getting 0 vector here. So I cross I is 0 vector, J cross J is 0 vector, K cross K is 0 vector. Is it clear? And also just let me tell you one more very very important thing. First let me shift everything. Okay, so when we, yeah, having said A cross A 0, yeah, I cross I 0 vector. Now what will happen if I write here I cross J? So see here I cross J will be what? I, magnitude of I, magnitude of J, then angle between I and J is 90 degree because x axis, y axis, z axis, three coordinate axes are mutually perpendicular. So angle between I and J 90 degree. So it will be sine 90 degree. Then here unit vector perpendicular to both I and J. Such unit vector is your K vector. So magnitude of I1, magnitude of J1, sine 91. So you are left with only K vector. So we can conclude I cross J equal to K vector. Similarly, J cross K, I vector, then K cross I, J vector. Okay, that means I cap cross J cap is K cap, J cap cross K cap is I cap, K cross I cap is J cap. So you may take like this. So these are in cyclic order. Okay, I am writing here I, J, K. So I cross J will be K, J cross K will be I, K cross I will be J. So if you reverse the order, it will be, sign will be changed. Just like no A cross B equal to minus of B cross A. Okay, so let me take the little bit, let me go with, yeah. Okay, so I'm just taking it here. Okay, now if you are given, suppose you are given A vector A1I plus B1J plus C1K. B vector is A2I plus B2J plus C2K. Now we want to find A cross B. Okay, now if I write here A1I plus B1J plus C1K cross A2I B2J plus C2K. Normal way we can write it here. Okay, now if I multiply as it is A1I A2I cross product. So A1 A2 I cross I 0. And this multiplied by this, I may write here A1 B2 I cross J is K. I'm just writing in detail, and otherwise I'll tell you the simplest thing also. A1 C2, A1 C2, now I cross K. See, K cross I cross K is minus J plus B1A2 J cross I minus K. Then this is 0 plus B1C2, now J cross K, I cap. Okay. Now C1A2, K cross I, J plus C1B2, K cross J is minus I. Then it is 0. So when you write like this, now it is actually what? If I write here I have I B1C2 minus B2C1 into I cap minus, if I write it here, let me take plus here also, no problem. J cap will be what? Here C1A2 minus A1C2 J plus A1B2 minus A2B1. Okay, so don't worry, you don't have to remember this huge product. You don't have to remember. The simplest way, if you just now look at this, no, it is actually this I, J, K, A1, B1, C1, A2, B2, C2. So determinant of this. So it means A cross B equal to determinant containing I, J, K, then A1, B1, C1, A2, B2, C2. Okay. So don't forget to write it in proper order. If it is B cross A, then it would be I, J, K, A to B to C to A1, B1, C1. And of course, whenever you interchange any two rows, sign of the determinant is changed. It means it is a proof that A cross B equal to minus of B cross A. Okay, so this is very simple, so you don't have to remember this much. Okay, you don't have to multiply like this every time. So while applying the product, while evaluating A cross B, simply you have to take this one. Okay. Next, third application is to find a vector perpendicular to two given vectors. So as we have discussed, direction of A cross B is perpendicular to both A and B. So if the question is find a vector perpendicular to A and B, so that vector will be your A cross B. Okay, so to find the vector which is perpendicular to both A and B, you can take cross product of the two vectors. So this is like this. Here you have A vector, B vector. So now A cross B will be like this. Okay, the vector which is perpendicular to both A and B. I mean to the plane containing A and B. Okay, now these are the simple applications. Okay, now third one is to find area of a triangle when its two adjacent sides are given. Okay, so let me show you. Yeah, we are given ABC triangle. Okay, now you have suppose A vector and B vector. Okay, now if you write like this, let me take, we know area of the triangle is half base into altitude. Suppose it is AD. Angle between two vectors is theta. Okay, now sine theta in triangle ABD, sine theta equal to what? AD by AB. Okay, it means AD by magnitude of A. Okay, so it means AD equal to what? AD means altitude of the triangle, that is magnitude of A into sine theta. Okay, now here area of the triangle is what? Area of the triangle, area of triangle ABC equal to half base. Base means magnitude of B into altitude, right? Altitude is, I mean you have to take like this. So it means it is half magnitude of B into magnitude of A sine theta. That is equal to what? Half of, this is magnitude of A cross B, right? So A cross B, magnitude of A cross B is magnitude of A into magnitude of B into sine theta. So it means area of the triangle ABC equal to half of magnitude of A cross B. So if two vectors are represented by two sides, two adjacent sides of a triangle, then the area can be calculated by taking the, I mean half of magnitude of their cross product. Okay, now in case you are given vertices, I'm just telling you here, suppose you are given ABC, okay, where vertices are given. So you are given the vertices, okay, and so if you are given vertices, so you can find any two sides. To calculate area here, you take any two sides. Suppose I take AB and AC, or AB and BC, or AC and BC. Any two sides, because any two sides you take, these two will be adjacent to each other. Okay, then area here, area will be half of magnitude of AB cross AC, or AB cross BC, or AC cross BC, right? So in case you are given vertices also, you can find any two adjacent sides, then apply this concept. Is it clear? Okay, next, to find area of the parallelogram. So here we have two cases when the sides are given. So the lecture is a bit lengthy because I just want to complete the whole concept in one go, so that in next class we can take the questions from both dot and cross products. Okay, to find area of the parallelogram when adjacent sides are given. So this is very, very simple in fact. Yeah, so whenever you have, this is ABCD parallelogram. So maybe you can take like this. So you can take A, B. Okay, so you are given two adjacent sides. I mean two adjacent sides are represented by two vectors. Angle between them is theta. So okay, here since we already have studied triangle part, so we don't have to worry here. So now area of the triangle ABC will be what? Area of triangle ABC equal to half of magnitude of A cross B, right? Now area of parallelogram ABCD. So this diagonal AC divides the parallelogram into areas, I mean two triangles of equal area. So area of the parallelogram is 2 times area of the triangle ABC. So it will be what? Magnitude of A cross B. Is it clear? Very easy. Yeah. The second step is when diagonals are given. Yeah, this is the first. Yeah, first part. Now second part. In case you are given diagonals. So this is also easy. So A, B, C, D. Okay, since we are taking magnitude, so we don't have much worry for plus minus sign here. Okay, suppose you have AC is D1 and BD is D2. And we know diagonals of a parallelogram bisect each other. Okay, so let the point of bisection, the point of intersection of two diagonals be O. Okay, so it means if I consider BOC triangle, okay, so BO vector is half of D2 vector. Okay, this is D2 vector. Just a minute. Okay, this is D2 vector. And OC vector is what? OC vector is half of D1 because diagonals of a parallelogram, they bisect each other. So here OB equal to OD, AO equal to OC. So area of triangle BOC equal to, again, BO and OC are two adjacent sides, half of magnitude of half D2 cross half D1. Okay, I'm taking here half BO, I mean half of magnitude of BO vector cross OC vector. BO vector is half D2. OC vector is half D1. So it means we are getting 1 by 8 of, this is magnitude, so you don't have any problem whether you write D2 cross D1 or D1 cross D2. So I'm writing here D1 cross D2. I'm taking the magnitude. Anyway, we don't have any problem in plus and minus sign. Okay, so now area of BOC is 1 by 8 of this. And we want area of the parallelogram. So area of the parallelogram ABCD will be 4 times 4 times area of triangle BOC. Okay. Now 4 times area of triangle BOC means 4 times 1 by 8 of D1 cross D2 the magnitude. So it will be 1 by 2 of D1 cross D2 the magnitude. Okay, so here not to be confused, because whenever you are given area of the parallelogram, so either you will be given 2 adjacent sides or you will be given 2 diagonals. So please read the question carefully. In case you are given 2 sides, or from the vertices you can find 2 sides. I mean, when you take 2 sides, it is magnitude of the cross product of 2 adjacent sides. But whenever you are taking the diagonals, I mean you are given the diagonals, or from vertices you are taking the diagonals. So area of the parallelogram will be half of magnitude of D1 cross D2. Okay, so this completes your total conceptual part of cross product of 2 vectors. Okay, and in next class we will be taking the questions. Until that time, please watch this video thoroughly. Okay, once you are very clear in concepts, so I don't think you will have any problem. Okay, so before winding up the class, I just want to touch one more point. Yeah. Okay, so just I think I should have told you here. Okay, whenever you are checking for 2 vectors parallel, yeah, collinear. So in that case, yeah, it is one of the applications to check whether 2 vectors are parallel, collinear or not. So what is the condition for 2 vectors to be parallel? So that condition I have to tell you here. Okay, so here to find, yeah, so here only. Now to check whether 2 vectors are parallel or collinear. As we know, 2 vectors are parallel or collinear. So if A cross B is a 0 vector, it means this should be completely 0, or you can say your A cross B should be 0 vector. Now this determinant to be 0, so you can take A1, B1, C1, A2, B2, C2, they should be proportional. Okay, either they are identical or they are proportional. So what we take here, 2 vectors are parallel or collinear if and only if the scalar components are proportional. Yes, let me write it here. So here to check whether 2 vectors are parallel collinear. So it means 2 vectors, A vector parallel to B vector if and only if A1 by A2 equal to B1 by B2 equal to C1 by C2. It means A1 by A2 equal to B1 by B2 equal to C1 by C2. It means we can say the scalar components of, corresponding scalar components are proportional, or we can say the direction ratios of 2 vectors are proportional. Okay, just to cross check, you can see whenever you have the determinant, okay, in that case, if any 2 rows are proportional or identical, A1 by A2, B1 by B2, C1 by C2, so you can get A plus B equal to 0 vector, right? So we have studied most of the properties and most of the applications. Okay, and I think whatever concepts we have studied, we have covered today, it is sufficient for your CBSE board exam. Okay, and again I request you to watch the video repeatedly so that you will be very clear concept wise. And in next class, we will be covering the questions related to this cross product and dot product. Okay, so thank you so much. So in case you find this video useful to you, you really can help your friends to go through it. I mean, you can share the video with your friends. Okay. Okay, so here, thank you so much for, studying, yeah, watching this video patiently, because I just wanted to finish all the concepts of this, cross product at one go. Okay, and see you next in the next class with questions related to dot product and cross product. Thank you so much.